Today we're going to be talking about reference triangles in two distinct ways. We're going to be talking about drawing a reference triangle from a given point and from a given angle. So let's say our first question is the one from our notes on page 2 at the end. Suppose theta is in standard position and negative 3, 7 is a point on the terminal side of theta. Draw a reference triangle and then find each of the missing angles and write each of the 6 trigonometric functions. Well, how do we do this? The first thing that we're going to do is we're going to look at our coordinate plane and we are going to draw our point. And since we have the point negative 3, 7, it's going to be in our second quadrant. The next thing that we do is from that point, we're going to draw a straight line down to the x-axis. And so we need to go from that point and draw it straight down from the x-axis. If our point was in the third or fourth quadrant, we'd go from that point up to the x-axis. And we create a 90-degree, we always create that 90-degree angle with the x-axis. The next step is then, after we draw our line down, our third step is to take the point to the origin. And so we're going to draw a slanted line from the origin to the point. And finally, it's where does our theta go? Our theta goes by the origin, but it goes inside the triangle. So that's where we draw our point theta. Okay, now we want to find all the missing angles. And when we do this, I'm going to get the tangent of 7 divided by a negative 3. Now, some people say, well, a negative 3, the length of that triangle can't be negative. But since we're in the second quadrant, we're going to find out in one of our next slides that our trig functions can be positive or negative depending on what quadrant they are in. And when we're in the second quadrant, our tangent of theta is actually negative. So we do need to keep that negative on the little leg there that we're using. So tangent of theta is going to equal 7 divided by a negative 3. Now when I find our theta, we're going to do the inverse tangent on our calculator. So we're going to do second tangent to get that inverse on there. And we're going to find that the second inverse, or the inverse tangent of 7 divided by a negative 3, is going to give us our theta of a negative 66 degrees. Now that negative 66 degrees is actually in our fourth quadrant because we always start drawing our angles from the x-axis at the 0 degrees, which is in our first quadrant. And so a negative 66 would actually be down. So what we're going to do is use a little bit of geometry, and we're going to push that angle over into the second quadrant, and I see that I have those opposite angles and that they are actually the same measurement. And then I'm going to take that angle and make it a positive angle, 66.801 degrees. Our second angle then, it's pretty easy since we have a 90-degree triangle. We're going to take 180 degrees, subtract 90, and then subtract our angle of 66.801. And so our second angle is just the 23 degrees there. Then we're going to write each of our 6 trigonometric functions. We've already found tangent, and we mentioned that tangent was negative. Now if we find cotangent, we know that it's the reciprocal, as we talked about in class, of our tangent. So to find cotangent, I'm just going to take the reciprocal of tangent, and that's how I get the negative 3 over 7. To find sine and cosine, though, I need my hypotenuse. And so I'm going to take 3 squared plus 7 squared equals the square root of 58. And I know what you're saying, Miss D, that 3 is negative, but it doesn't really matter if the 3 is negative or positive because we're going to square it. And what we're going to find out is that our hypotenuse, or that length, which we're going to find out in vectors is called our magnitude, is always going to be a positive number. So we do get a positive square root of 58 there. All right, now let's find our sine. Since our sine is our y value, or our opposite angle, you'll notice that our sine in the second quadrant is always going to be positive. So we're going to have a sine of 7 divided by the square root of 58. Oh dear, but we also learned in class last time that we can't have a radical in our denominator. And so what we're going to do is we're going to multiply that sine of 7 divided by the square root of 58 times the square root of 58 over the square root of 58, and I get that 7 times the square root of 58 over 58 and get that radical out of the denominator. And otherwise we're rationalizing our denominator. All right, the next thing we want to do, sine always goes with cosecant, and we know we want to take the reciprocal of sine to find our cosecant. So instead of taking our rationalized answer, we're going to go back to our original because I would hate to mess up that other one. Looks a little tough to unrationalized. So we're going to take the rationalized version so that I know that cosecant is just that square root of 58 over 7. So we want to make it as easy as possible for us. All right, now we're going to find cosine, and you'll notice cosine uses our x value, or a negative 3 in the second quadrant. So our cosine in the second quadrant is actually going to be negative. And again, we're going to have to rationalize our denominator because our denominator is a hypotenuse, which is the square root of 58. So we'll end up with negative 3 square roots of 58 over 58. And then cosine always goes with secant. And so secant, we're just going to take the reciprocal of our unrationalized part of the cosine, and I'm going to get a negative square root of 58 over 3. And again, it doesn't matter which one I make negative, but really the 3 was negative. All right, now, how do I remember then if I'm in my first, second, what if I have something in the third or fourth quadrant and I have to draw a reference triangle there? How do I know whether sine or cosine is positive or negative in tangent? Or there's a little saying, of course, that we use to help us remember that. So we're going to look at that now. So where trig functions are positive and negative. In the first quadrant, all functions are positive and negative, and that's because we know in the first quadrant that our x and y's are all positive in the first quadrant. So if I'm dividing things, an x and a y that are both positive, my trig functions are all going to be positive. But if we move to the second quadrant, we take this saying all students, and we see that we have this S underlined in students. That goes with sine. That's given us a hint that our sine and then our, of course, reciprocal of sine, which is our cosecant functions, is also positive. So sine and cosecant are positive. All other trig functions in the second quadrant are negative, as we saw in our last example. All right, let's move to the third quadrant. So we have all students take in the third quadrant. And guess what take stands for? The T stands for tangent. So you'll notice that tangent and cotangent function are all positive in the third quadrant, and all other trig functions are going to be negative. And then, of course, in our fourth quadrant, we have all students take calculus. The C in calculus is telling us that our cosine, and then what goes with cosine? Well, don't we remember it's secant, so our cosine and secant functions are all positive and all others are negative. So don't forget all students take calculus. Helps us remember as we go around the unit circle that we're going to learn in our next unit, but as we go around this quadrants, we'll see where our trig functions are positive and negative. All first quadrant, everything's positive. Second quadrant, students goes with sine, sine's positive, and its companion and cosecant are all positive, all others are negative. In the third quadrant, take, tangent's positive along with its compadre cotangent, all others are negative, and in the fourth quadrant I have calculus, which goes with cosine, etc. All right. A second way to draw a reference triangle is from a given angle. And a question might be something like this: diagram 113 degrees showing the reference angle, and use the reference triangle to find the missing angles in the 6 trig functions. All right, so what I would do is I would start from 0 degrees from the x-axis in the first quadrant, and I would draw around the quadrants until I got to 113 degrees. And I could use my protractor or something like that to do that. Now I'm going to draw that as a ray, and that's the blue line is what I would draw first in this case. So I'd actually draw the angled line in this case first, and then I would draw the green line down. You'll notice that I use the same green line we used in our other example, but I could have actually drawn that green line anywhere, it doesn't matter. When I want to find theta then, I'm going to take 180 and subtract that 113 degrees to find theta, which is 66.801 degrees, just like we had in our first example. To find a trig function then, we would use either the larger angle, 113, or the smaller angle, 66.801, and I would almost get the same answers. The difference is if I use the larger angle, I actually get those positive and negatives that we were talking about correctly from my calculator. So I choose to use the larger 113 degree angle that creates the terminal side of my reference triangle, but you can also use the 66.8. I'll show you that in a minute. So if I take the sine of 113, I get 0.919. If we remember our other example, that was where our side was 7, and I divided it by the square root of 58, which was our hypotenuse. If I do that, if I take that, I would get a 0.919. So it's exactly the same thing, we're just doing it a different way. On the cosine, if I take the cosine, I'll get a negative 0.393, which again would have been that negative 3 divided by the square root of 58, and the tangent would have given me, of 7 divided by negative 3, would have given me this negative 2.333. Now again, I told you that you could also take the 66.801 degree and use it for sine. For sine it wouldn't matter because it would give me both positive answers, and sine in the second quadrant, as we found out, is positive. The problem is when I try to do that with cosine, if I took the cosine of 66.801 degrees, I would have gotten a positive 393 back from my calculator, and we need to remember, if we were on a quiz or a test, that we would have to put a negative in front of that 393 because cosine in the second quadrant is negative, and the same thing would actually happen with tangent. If I put tangent of 66.801, I would have gotten a positive 2.333, and I would have needed to know that I need to put a negative in front of that. So that's why I use actually the larger angle, but again, it doesn't matter if we remember this, the little saying that we did before, all students take calculus. Okay, well that's it for this example. Again, we showed you how to draw a reference triangle from a point and from a given angle. There are several of these in your homework, so hopefully you'll practice these on your homework and you'll do well on your quiz on Monday and Tuesday. Thanks guys, and please email me if you have any other questions. Take care, and I will see you in class on Monday.